Up to now, everything we discussed happens before execution or around execution. Now we address a deeper question. How do we prevent invalid execution paths from ever existing? This is where types enter the picture. Most developers are taught that types exist to describe data. That explanation is harmless and incomplete. Types do not exist to describe data. Types exist to forbid nonsense. A backend system does not fail because it does not know what data is. It fails because it allows operations that should never have been possible. Types are one of the strongest tools we have to stop those operations before execution. Types exist to constrain runtime behavior. A type does not store anything. A type defines which values are allowed, which operations are legal, which execution paths are invalid. When you declare a type, you are not adding information for the computer. You are removing freedom from execution. That is a feature: values, variables, and state. A value is concrete runtime data. A variable is a named storage location that may hold a value. This distinction matters because values flow, variables persist temporarily, and execution manipulates variables via values. Confusing values with variables leads to bugs where developers believe data is stored when it is merely computed. State, remember, is just the set of variable value associations at a moment in time. Types constrain what those associations are allowed to be. A reference is a value that points to an object. It is not the object. This single idea explains shared state, aliasing bugs, unexpected side effects, and many concurrency issues later. When two variables hold the same reference, they do not hold the same value. They hold access to the same state. Types do not prevent this. They merely define what kind of object the reference may point to. This is why type correctness does not guarantee behavioral correctness. It guarantees structural validity, not safety. Identity versus equality. This leads to another essential distinction: identity answers. Are these the same object? Equality answers. Do these represent the same value? Backend failures frequently occur when systems assume equality implies identity, or the reverse. Types do not resolve this confusion automatically. They only give you the vocabulary to reason about it. Invariance. Correctness over time. An invariant is a condition that must always hold true during execution. Examples: balances never go negative, states never contradict themselves, references never point to invalid objects. Types help encode invariants, but they do not enforce all of them. Senior engineers understand this boundary. Types prevent illegal forms. Invariants prevent illegal states. Confusing the two leads to overconfidence. Primitive versus reference types. Why Java cares. Java distinguishes between primitive types, values stored directly, reference types, pointers to objects. This distinction exists because execution cost and semantics differ. Primitive values are copied, are independent, do not share state. Reference values are copied references, may share state, may introduce aliasing. Mental models to lock in. Types exist to forbid invalid execution. Types constrain behavior, not data. Values exist at runtime. Types exist before it. If you misunderstand any of these, Java will appear unpredictable later. Common misconception. If it compiles, it's correct. No. If it compiles, it is structurally valid. Correctness is a stronger claim, and types are only one layer of defense. Why this matters for backend systems. Backend systems fail most often not because of syntax errors, but because state evolves incorrectly, shared references behave unexpectedly, invariants are violated silently. Types dramatically reduce the surface area of such failures, but only if you understand what they do and what they do not do.